Assalamualaikum warahmatullahi wabarakatuh. Today our group will be presenting on our project entitled of Classification using Logistic Regression Algorithm for Bank Marketing to Predict Customer Subscription of Term Deposit. Next, let me introduce our team members based on their sequence in presenting today. First of all, my name is Nur Chahlani binti Misno, and I'll be presenting on Introduction and Literature Review. Second, Musda, she will be presenting on datasets and data visualization. The third one, Nur Liana, she will be presenting on data cleaning with logistic regression model. And lastly, Mas Liana, she will be presenting on knife bias model and analysis with conclusion. For the introduction, I will give brief introduction of what is our project is all about. First of all, the purpose of this project is to study which algorithm is better in classification. Is it knife bias or logistic regression? To understand the motivation behind our project, let's look at the problem statement. Logistic regression is a linear classifier over the continuous random variable. The linear classifiers produced by logistic regression and Gaussian knife bias are identical in the limit as the number of training examples approaches infinity, provided the knife bias assumptions hold. However, knife bias will cause it to perform less accurately than logistic regression in the limit if these assumptions do not hold. In other words, naive bias is a learning algorithm with greater bias but lower variance compared to logistic regression. If this bias is appropriate given the actual data, naive bias will be preferred. Otherwise, logistic regression will be preferred. As logistic regression and naive bias are linear classifier, and when they are far from linearly separable, both will not perform well. Therefore, the performance of this algorithm needs to be compared to their asymptotic errors. In most cases, logistic regression performance did not catch up to that of naive bias, observed in particularly small datasets. Therefore, we are trying to prove the theories that logistic regression will eventually catch up and outperform naive bias if the datasets are particularly quite large. So, we came up with this project objective. First, to study the logistic regression algorithm. Then, we develop model using logistic regression for bank marketing datasets. Then, we develop model using naive bias for bank marketing datasets. And eventually, we will evaluate the performance of each models in 2 and 3 to compare and come up with our own summarize of our results. Hence, our project scope, we will start by finding the suitable datasets to be tested in both algorithms. After that, the data will undergo data pre-processing process, and then we will split the datasets into training datasets and testing datasets that we will test it and train in using R script for both algorithms. By the end, we compare both performance analysis to come up with the conclusion which algorithm suits the dataset better. So, as has been mentioned, the chosen algorithms are naive bias and logistic regression. So, for the literature review, I will give brief introduction of what our research on logistic regression have found out. So, logistic regression is a statistical method for analyzing a dataset in which there are one or more independent variables that determine an outcome. The outcome is measured with a dichotomous variable. It means there are only two possible outcomes, either 1, true or success, or 0, failure or false. The goal of this algorithm is to find the best fitting model to describe the relationship between the dichotomous characteristic of interest and a set of independent variables. There had been research studies showed that a very simple parameter-free implementation of logistic regression is sufficiently accurate and fast to compete with state-of-the-art binary classifiers on large real-world datasets. As we know, there had been applications using life sciences data mining, threat classification, and temporal link analysis, collaborative filtering, and text processing. In several of these applications, logistic regression was preferred over other tools. As proved by Comeric and Moore in 2015, logistic regression can be used to model the relation between many input variables and a binary output variables. Though logistic regression is a linear classifier in that it produces a linear decision boundary, this does not seem to be a problem for high-dimensional classification. Naive Bayes classifiers are a family of simple probabilistic classifiers based on the so-called Bayesian theorem with strong naive independence assumption between the features. Hence, it is particularly suited when the dimensionality of the input is high. Despite its simplicity, naive Bayes can often outperform more sophisticated classification methods. It can handle an arbitrary number of independent variables, whether continuous or categorical. In Lode and Domingo research, it is stated that although naive Bayes have been widely used for clustering and classification, they are seldom used for general probabilistic learning and inference. While Ng and Jordan research has stated that naive Bayes was concluded to have a setback or weakness against larger set of data. This is because as the number of training examples is increased, one will expect generative naive Bayes to initially do better, but discriminative logistic regression will eventually catch up to and quite likely overtake the performance of the naive Bayes. That is all from me. Thank you.
Bismillahirrahmanirrahim. This is Mujda Baraksai. For this part of the video, we're going to talk about the dataset. The dataset for our project contains 41,188 rows and 17 columns. There are 16 columns in the table that provide information about each client. For example, the age, material status, the education level, and so forth. A subset of these are related to the last content of the current campaign, such as the month and the day of the week and the last contact was made, and those more information. For this dataset, as you can see, we have provided some rows and columns in our slides. For the next part of it, we are going to talk about the visualization of the data. For the visualization of the data, we have used the so-called the application which is Azure, and for this part we have choose the three of the visualizations, which are the relationship of the month and the duration, the relationship of the job and education, and relationship of the duration and balance. For the relationship of the month and duration, the figure shows that there's noticeably more duration than other months in this month. So it can be concluded that more customers called the bank during the month of the May, and it may be because of the celebration of some festivals. We have searched for the festivals or the most important economical events in this country. So we have found that there are some festivals that may affect the call of the users to the bank. For the next one, which is relationship of job and education, there is a correlation between the job and education for the month of August. From the figure, it is obvious that the higher the level of education is, the stable and the more and the better the job is and can be obtained by the customers. For the other visualization of the data, we have choose the figure of relationship of the duration and the balance. So for this figure, we can see that there's a correlation or relationship between the duration and the balance. It is clear that the customers with higher amounts of money in their accounts are spending more time to call to the bank, to have communication with them, and it has a really important relationship. The amount of the money in the bank account and the duration of the call and the number of the duration of the last call to the bank. For example, they may got 10 minutes on the call, they may got 5 minutes, they may got 15 minutes, and so on. Thank you so much.
Then we move to data pre-processing. In data pre-processing, we will do data preparation, exploratory data analysis, and decision tree. In data preparation, we check for the missing values if there is any. Then using subset, we select the 9 variables that have significant values in affecting the outcome of whether the customer has subscribed to term deposit or not. After that, we rename the variables to a more sensible means and convert the data types of the variables to a numeric and factor respectively. Next, in exploratory data analysis, we found some inconsistencies in the summary of data, such as the mean and the median are not similar in values, and the maximum values is to differ from the tag quantile. Hence, we visualize the variables in histogram to see if there is indeed outliers in the data. As it can be seen from the histogram on the last contact, most of the customers' last contact duration are in between 0 to 1000 seconds. However, there is one customer that has not contacted the bank for 3025 seconds in duration. It is also can be said the same for histogram of previous contacts. When most of the range is between 0 to 10, there is a customer that has been contacted 25 times previously. In the box plots shown based on customer age, there are some outliers detected. Supposedly, most of the customers aged 17 and above are retired. However, there are some of them still work as blue collars, management, and technician. Inversely, there are several customers that is between age 20 and 40 is classified as retired. Moreover, the customer age 40 and above are supposed to be working and not classified as students. Thus, the outliers found are removed and corrected. After that, we create a decision tree to see which of the 8 variables has the most significant values in predicting the target outcome. As it can be seen from the decision tree, last contact is the most important variables, followed by previous outcome, jobs, housing loans, and others. Next, we create the model for logistic regression by splitting the data to 75% for training and 25% for testing. In performance evaluation, we can see that the logistic model has 91.42% accuracy and kappa value is 0.37, which is indicating it has weak agreement. The model is also 29.0% sensitive toward positive values and 98.58% sensitive toward negative values. For area under the curve of the graph sensitivities against specificity, the model has the AUC of 0.854. Then, we validate the model using k-fault validation with k equal to 10, which means the model will repeat the training for 10 times. The result of the evaluation is then compared to original one, and it can be seen that the accuracy of the model has slightly decreased from 91% to 90%. Furthermore, kappa value has also decreased slightly from 37 to 0.29. However, the sensitivity of the model toward positive values has greatly reflected from 29% to 99%. Inversely, the specificity of the model has dropped from 98% to 21%.
Now, I will be explaining about naive bias. First, the data set is split into two, as we did for logistic regression model. 75% of the data is set to train the model, while the other 25% is set for testing. Naive Bayes model is created with 5 predictors. As we can see, this table shows the results we obtained from evaluating the naive Bayes model. The data is 88.67% accurate. It is 1.5% sensitive to positive values and 100% sensitive to negative values. The kappa value is 0.0269, which is less than 0.2. This indicates the algorithm has poor agreement. The ROC curve gives 0.842, which is higher than the 0.8. It means the model does a decent job in discriminating between 5 categories which comprise the target variable. Moving on to the next slide. The next slide is about k-fault validation. We use k-fault validation to validate our model. So basically this table shows the result we obtained based on k-fault validation comparing to the model performance evaluation. Basically, accuracy, kappa value, and AUC have the same values, 0.886 and 0.886, 0.0269 and 0.0269, 0.842 and 0.842. However, for sensitivity, from 0.015, it increases to 1.0. Specificity from 1.0 drops to 0.015. Now, analysis and conclusion. So, this table is the result that we obtained from both models that we have done, logistic regression and naive Bayes model. So, this table is used to compare to know which model is better in predicting target variable. So, as we can see, logistic regression is a better model for predicting the classification of this data set because it has 91.43% accuracy as compared to naive Bayes, which is only 88.67% accurate. However, naive Bayes is more precise because it is 100% precise, while logistic regression is only 98.57%. Furthermore, kappa value for logistic regression indicates it has a weak agreement, whereas for naive Bayes it indicates that it has a poor agreement. The next slide is about the ROC graph. This ROC graph is actually based on sensitivity and specificity. So, sensitivity of logistic regression is 0.292. whereas the specificity is 0.985. The sensitivity of naive Bayes is 0.015 and specificity of naive Bayes is 1.0. Therefore, it produces an AUC of 0.854 for logistic regression, which is the red one, and 0.842 for naive bias, which is the blue one. So it shows that naive bias is lower than logistic regression. So conclusion, what we have obtained is, based on our findings, it is proven that logistic regression has a better performance when handling large data set compared to naive bias, because there is a research done by Comrade and Moore stating that LR software found is often reasonable to use in large multi-class problems. So our result and the study done by them matches. Therefore, we will conclude that logistic regression is a better model for prediction. Thank you.